Hello everyone and welcome back to the second video on our series on UPSC Civil Service Mains PYQ of Mechanical Engineering. So this is video 2 or you can say the day 2, and today we will solve 3 questions of UPSC 2021 Mains of Mechanical Engineering. So without wasting any time, let's start, and today my speed will be more than usual because we have to solve 3 questions. So cope up with it. So first question is, in a TIG welding of 2 sheet 5 thickness performed using the welding current I is equal to 200 ampere. So I is 200 ampere and voltage is given as 12 volt, and assume 70% of the generated arc heat is utilized for melting the base. That means efficiency or heat transfer efficiency it is given, it is 70%, that is 0.7. And if the steel is being welded needs 20 joule per mm cube of heat for melting, so specific heat sh specific heat is given as 20 joule per mm cube for melting. Then determine the following: power of a welding arc, rate at which energy is delivered for melting, and volumetric rate. So power of welding arc, P is equal to V into I. So simply put, 12 into 200, that is you will get 2400 uh, watt. So this is the answer of first. Power of welding arc, the rate at which energy is delivered to the melting. So energy delivered, so energy delivered ED is equal to efficiency, heat transfer efficiency, multiplied by the power rating. So here efficiency is 70%, so 0.70% multiplied by 2400. So here you will get 1680 watt. So this is the answer of second question, rate at which energy is delivered for melting. The third one is volume rate at which the weld metal is produced. So energy delivered, whatever the energy is delivered to the weld metal, that is it is given by specific heat multiplied by volume. So we know the here energy delivered is what, 1680 watt, and what is the specific heat, it is given 20 joule per mm cube. So volume rate V we can find here from our 168 divided by 2, that is 84. So here it is a 84 mm cube per second. So this is answer of all 3 questions. This is a very simple problem of 10 marks, so anyone can get the 10 marks very easily. So next question, this is also very good question, and this question can be asked in the PSU exams as well, or gate exam also in 1 marks question. Okay, and in engineering service prelim they can also ask. So the question is, a high speed steel cutting tool during the turning aluminum offers a tool life 3 hours at cutting speed 60 meter per minute. Here let me tell you first thing that what we have to do is we have to use Taylor's tool life equation. Vt power n is equal to c. Here it is a tool life exponent n is given 0.27, and just be careful while you in units. So whatever we derive the equation, the velocity is in meter per minute, and time here we have taken in minute while deriving this equation, but here time is given in hours, so be careful on that. Or other we can, in other manner we can say that v1 t1 power n is equal to v2 t2 power n. We can write this equation in that manner also. So we will use this format. So what is the tool life when we will operate at 80 meter per minute? So initial v1 is 60 meter per second, v1 is 60 meter per second, and sorry, meter per minute, sorry, and tool life is 3 hours, so 3 multiplied by 60 power 0.27 is equal to, what is the velocity, what will be, sorry, what is the tool life if it will operate at 80 meter per minute, and what time power 0.27, or we can say the t2 power 0.27. So when you solve this you will find in the answer that t2 will be 62 minute. Okay, 62 minute only. So this is the answer of first question. And second, the cutting speed at which the cutting tool will have to be tool life 2 hours. So again use this v1 t1 is equal to v2 t2, but here I will use the notation v3 t3. So initially 60 meter per minute, multiply by 3 hours, convert into minute, power 0.27 is equal to V2. We have to find that velocity, sorry, V3. And what is the tool life? 2 hours. So it is 2 into 60 power 0.27. So when you solve this, so you will get the velocity, cutting tool velocity is 67 meter per minute. So this is a quite simple numerical. Now the third, and this is the most important, because this kind of question similarly asked in GATE 2020. The similar kind of question has been asked in GATE 2020 exam, as well as the chances in upcoming exams also, as well as in a mains exam of engineering service with theory of electrochemical machining combined. So what the question is, here I will not write the given data separately. I will just mark over here. The frontal working area of electrode is 2000 mm square. So capital A is given in certain electrochemical machining operation, which is applied at a current 1800 amps. So current is given I, and the voltage is 12 volt. So voltage V is also given, and the material being cut is nickel and having valency 2. That means Z is equal to 2. Whose specific material removal rate, specific material removal rate, SMRR, 3.42 10 power minus 2 mm cube per ampere second is given. If process is 90% efficiency is given. So find out the material removal rate, MRR, in meter cube per minute. So first of all solve this first part. So material removal rate is given by specific material removal rate multiply by current multiply by efficiency. So put all this data, 3.42 into 10 power minus 2 multiply by 1800 amps current and efficiency 90%. So when you solve this, you will get the material removal rate, that is 55.40 mm cube per second, but answer is in meter cube per minute. So 55.60 multiplied by 60. So you will get the answer as 3324.24 mm cube per minute. So this is the answer, material removal rate. And last is, if the resistivity of the electrolyte is resistivity rho is 140 ohm into mm, determine the working gap. So we have studied the one equation, resistance of any material is given by rho into h divided by a. Actually we have studied rho into l by h, but here we have to uh, do the calculation for gap. So here h is the gap, a is the frontal area, rho is the resistivity, and here resistivity is in given in ohm into mm, and gap we also required in mm. So area should be in mm square. And but now we don't have the value of resistance, so how we can find? Using Ohm's law. V is equal to IR, because voltage is given as 12 volt and current is given as 1800 is equal to R. So put this value over here. So 12 divided by 1800 is equal to, what is the resistivity? That is 140 into gap is h that we have to find, and frontal area is 2000 mm square. So when you solve this in calculator, I am not doing the calculator part calculation, okay. So you will find h is equal to 0.095 mm, or nearmost answer, that is sorry, or the nearmost answer is 0.1 mm. This should be the electrolyte gap. So this is the answer of this question. The other thing, that is a main thing, that is one equation that we can also use based on the question, the material removal rate, MRR, that is I into atomic weight small a divided by rho density of material multiplied by Faraday's constant and multiplied by number of valencies. So this equation can also be useful, but for that the data should be given in such a manner that, okay. So this is the another equation that is useful. and the question asked in the GATE examination was based on this equation. I hope you like this solution of these three questions, and tomorrow we will see some new questions also of the 2021 paper itself. Thank you for watching this video. Hope you like this and subscribe this channel for upcoming daily this kind of videos. Thank you.